complex numbers, first of all, you have to see the need for it. What value for x will make this true? X squared equals 4x minus 7. What would you do? Well, you probably would go x squared minus 4x plus 7 equals what? 0. So what we're essentially doing is finding the zeros. So we look at quadratic formula, and you'll say, oh, x, the answers for x will be minus b, which is 4, plus or minus the square root of b squared, which is 16, minus 4, times a, which is 1, times c, which is 7. But the meaning divided by 2a. The meaning behind it is what value for x in this quadratic will equal 0. And as it turns out, we're going to have 4 plus or minus the square root of 16 minus 28, which is negative 12 over 2. Now, what's the problem with that? It doesn't exist. So there's a whole branch of mathematics that says, okay, it doesn't exist, but what is it that makes it so it doesn't exist? The 4 over 2 is fine. The square root of 4 is fine. Square root of 3 is fine. But the square root of negative 1 is the only part that isn't fine. These would cancel out. You'd get 2 plus or minus the square root of 3. This square root of negative 1 is the problem. Well, that square root of negative 1, we're going to dub I. We're going to give it a name. We're going to call it I. It's a symbol for the square root of negative 1. And because of that, all kinds of weird things are going to happen. Oh. Oh, I just solved it for the quadratic formula. And this is why we have the square root of negative 1. This is why. It's one of the results. Now, what can you do with these I things? Well, the I things are usually put together with real things. So on a number line, you usually have a real part and an imaginary part. The way it's represented is x and yi. And y times I gives you the imaginary part, and x is the real part. So when you see something like 2 plus 3i, that's called a complex number that combines the real and the complex. And the reason you do that is that, one reason you do that is, how many of you ever get messed up with 3, 2 to graph? Are you like me? Emily, you sometimes get mixed up. You will go over 2 and up 3. That happens to me all the time. So with a complex, engineers will use this so that we're going over 3 in the real and up 2i in the imaginary. And now, because you're stating it this way, there's no way you're going to get them mixed up. That's another reason why we use I. And then you can also look at electrical and magnetic fields and magnetic energies. And what happens there is that the real part can be controlled by one variable and the imaginary part can be controlling the other. And you can solve one equation, two unknowns with one equation. That's another. So that part's fine. Let's go to adding and subtract. So how about 2 plus 3i, and you're going to add 4 minus 2i. How hard is that? Easy. You get 6 plus I. Can you subtract? Absolutely, no problem. Can you multiply those? 4 minus 2i. Well, you'd have to FOIL them. So 2 times 4 is 8. 2 times negative 2i will be negative 4i. Then 3i times 4 is 12i. And then 3i times negative 2i is negative 6i squared. So if I is the square root of negative 1, what's I squared going to be? It is negative 1. Okay, not 1. You need to go to the 4th power to get to that. So this could simplify to 8 minus 8i. And then this is negative 1. So what's negative 1 times negative 6? plus 6. So multiplying these two, you're going to get 14 minus 8i. So it looks like we can add, we can subtract, we can multiply. What can't we do? Wrong. We can do that too. We can do that. The way we do it is we get rid of the denominator with the I in it. And the way you're going to do that is by multiplying by, you remember, the conjugate, 4i, 3 plus 4i. Just a second. And then you just multiply and simplify and things will work out. We will play around with the trigs tomorrow. Your assignment is to do the complex and finish up those parametric multiple choice.